The universe is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. When you look up at the night sky, you see only a tiny glimpse of our cosmic neighborhood. Beyond those stars lies an ocean of galaxies, each with billions or trillions of stars stretching in every direction. The light from the most distant objects we see has traveled over 13 billion years to reach us. The universe is filled with profound mysteries. How did it begin? Are there other planets like Earth? Are we alone? We are explorers, building tools to extend our senses and unlock the universe's secrets. This cosmic ocean is not just empty space, it's a dynamic, ever-changing environment. Stars are born, live for eons, and die in spectacular explosions, seeding the cosmos with the building blocks of new stars, planets, and life. Everything we are was forged in the hearts of stars that died long ago. We are, quite literally, made of stardust. We can't travel to other galaxies, yet. Instead we build telescopes, our eyes on the cosmos. Telescopes collect ancient light, each photon carrying clues from across space and time. By studying that light, we unlock the universe's secrets, one discovery at a time. It's a journey of the mind, powered by science and wonder. The universe is the ultimate puzzle, and we've only just begun to piece it together. Our quest is just beginning. The story of the cosmos is waiting to be explored. Our journey began with a simple tool, Galileo's telescope. 400 years ago, Galileo pointed his handcrafted telescope at the sky and saw mountains on the moon, moons around Jupiter, and a universe more complex than anyone imagined. That was the spark of modern astronomy. Over centuries, telescopes grew larger and more powerful, revealing that fuzzy smudges were actually other galaxies. In 1990, we launched the Hubble Space Telescope, giving us a crystal-clear view of the cosmos from above Earth's atmosphere. Hubble delivered stunning images and helped us measure the age and expansion of the universe. But Hubble had limits. It couldn't see through cosmic dust. To peer deeper, we needed a new kind of eye, a telescope that could see in infrared. Enter the James Webb Space Telescope, or JWST. Launched in 2021, Webb's massive gold-coated mirror captures faint, ancient light from the dawn of time. Webb is 100 times more sensitive than Hubble, and sits 1 million miles from Earth, where it can stay cold enough to detect the faintest signals. It's not just a successor to Hubble, it's a revolutionary new tool for discovery. With Webb, we're seeing the universe as never before. The next era of exploration has begun. The James Webb Space Telescope is more than a telescope, it's a time machine. Because light takes time to travel, looking at distant objects means seeing them as they were in the past. Webb's infrared vision lets us see farther back than ever, to the first galaxies after the Big Bang, over 13.5 billion years ago. It's like reading the first chapter of a book we've only ever read from the middle. Webb can also see through cosmic dust, peering into stellar nurseries where new stars and planets are born. For the first time, we're watching the process of creation unfold. Webb studies exoplanets too, analyzing starlight filtered through their atmospheres to search for water, methane, and other molecules. This is a huge leap in the search for habitable worlds. We're not just counting planets, we're beginning to understand what they're made of, and if they might support life. Webb is opening a new window on the universe's past and its possibilities. The secrets of creation are coming into focus. In 2021, astronomers noticed a distant star, Assassin 21QJ, suddenly dimming in infrared light. The cause was a mystery, until Webb turned its gaze on the star in 2024. Webb revealed a massive glowing cloud of dust, the aftermath of a colossal collision between two giant planets. The impact vaporized huge parts of both worlds, creating a superheated plume that cooled into dust and blocked the star's light. This was the first time we'd witnessed the immediate aftermath of a giant planetary collision in another solar system. Webb's data let scientists study the energy and composition of the debris, offering a direct look at how planets are built and destroyed. It was a landmark discovery showing us planetary formation in action. The universe's most violent processes are now within our reach. The Assassin 21QJ collision confirmed our theories about how planetary systems form. Early solar systems are chaotic. Planetesimals collide, sometimes merging, sometimes shattering. The Webb discovery showed these massive impacts still happen today, shaping new worlds. The debris cloud from the collision may eventually form new planets or moons. This echoes our own history. Earth's moon likely formed from a similar impact, and Uranus's tilt may be the result of a giant collision. Webb's analysis of the debris gives us a rare glimpse inside ice giant planets, refining our models of planetary composition. Each discovery adds a piece to the puzzle of how worlds are built across the cosmos. We're witnessing the birth and evolution of planets in real time. Webb isn't just looking at distant galaxies, it's revolutionizing our view of our own solar system. It's captured stunning images of Jupiter, studied Saturn's moon Enceladus, and revealed secrets in the Kuiper Belt. These icy bodies are cosmic fossils, preserving the ingredients that built our planets. Webb's sensitivity lets us study these distant worlds in detail, tracing our own cosmic origins. Every discovery connects us to the universe, helping us understand Earth's story. The journey is far from over. Webb is just getting started. Each new image and data point challenges our assumptions and inspires awe. We're living in a golden age of discovery, finally able to answer humanity's oldest questions. For every answer, the universe offers new mysteries. The cosmic journey continues,